Hi class, today we're starting a new chapter, 9.1. We are going to be making scatter plots and understanding what scatter plots are. So in your workbook, page 185, or for period 8-9, you'll get a handout of this. We have different types of sports balls. There's a horizontal axis and a vertical axis. Okay, your x-axis, they tell you, are the weight in ounces. Your vertical axis is your y-axis, and that is the circumference in inches. So now what you need to decide is what scale are you going to use to show the relationship between the different types of balls. So you're going to look at all your x values and find out what's the smallest one and what is the biggest one. Okay, 1.4, 21, 5, 15, 7, 16, 2, and 10. So it looks like we need to go from 1.4 through 21. So 1 through 21. So maybe you want to count by threes on your x-axis. Now let's take a look at our y-axis. Change colors. And we want to look at the other numbers. So look at what those numbers range from. Okay, so they go from 5.3 to 30. So maybe you want to count by fives on your y-axis. Plot those points, and then we will take a look at the relationship between those points. Okay, so you graph them, and you'll notice that you have a bunch of points, maybe scattered around like that. Those are not the exact locations, but you'll get the idea. So the line is going in an upward direction. So as we mentioned before when we talked about slope way back when, okay, the line is going in upward direction. So there's a positive correlation or a positive relationship between the weight of the sport ball compared to its circumference. Okay, so what is a scatter plot? You need to put this in your notes. Scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs. So make sure you write what a scatter plot is. Outliers you guys learned about last year, but we might need a little refresher. An outlier is a value that lies outside the data set. So it's either really, really small compared to the data set or really, really large. So here's an example here. And you can see about 9.5 would be your outliers compared to the other set of data. In this set given here, we have 3, which is really, really low compared to that set of data, and 85, which is really, really high. This is also a review from last year. A gap is a separation in the data set. So there is a gap between maybe about 500 to about like 900. And a cluster is where most of the data is located. So in this example, maybe it's negative 300 through maybe positive 300, okay? A positive linear relationship, okay, most of the points go in an upward direction. The points lie close to the line, like it almost makes a line, and a positive relationship as x increases, y increases. So an example of this could be the more you study for a test, the better your grade, because your x value is increasing and your y value is increasing. Hopefully you're taking notes on this. A negative linear relationship, the points lie close to a line, but it's going down. So as x increases, y decreases. So as the weather gets warmer, the amount of layers that we wear become less, decreases. So one goes up, one goes down. That will form a negative linear relationship. A nonlinear relationship, say a lines and a curve, would look like that. And no relationship, dots are all over the place. There's no pattern whatsoever. So there's no relationship at all. Okay, the scatter plot shows the amount of fat in grams and the number of calories in 12 restaurant sandwiches. So my x-axis is the fat in grams, and my y-axis shows me the calories. So how many calories are in the sandwich that contains 17 grams of fat? So fat is my x-axis, so I go over to 17. I go up. Where do I hit that dot? At 400 calories. So A is going to be 400 calories. B, how many grams of fat are in the sandwich that contains 600 calories? So now we're looking at our y-axis going up to 600. Where do I hit the dot? I hit it at 30. So there's 30 fat grams, 30 grams of fat. So what tends to happen to the number of calories as the number of grams of fat increases? So let's look at our line. It's kind of in a positive direction. So as the number of fat gram increases, so do the calories. The calories also increase. So it's a positive relationship. Okay, describe the relationship between the data. Identify any outliers, gaps, or clusters. Okay, so I see many points that kind of form a line, right? So let me just draw it in here. So it's a positive relationship. As the television size increases, the price increases. And so it's a positive relationship. And there's an outlier. Where is the outlier located? Out here. So we're going to say it's about 70, about 2,200 maybe. Okay. Then we have a cluster where most of the points are right about there. So they're under 500. Okay, and the gap. Where do you see the gap? Let me erase this so you can see it. The gap is between 500 and 1,500. Between 500 and 1,500. Okay, so that's all for, that's all for A. B. Age and number of pets owned. Well, is there any relationship? There's no pattern there, so there's no relationship between your age and the number of pets you own. Okay, you're going to make your own scatter plot on the graph paper that I'll hand out to you, and you're going to identify any outliers, gaps, or clusters in the data. You also need to find your range between your x values, so you know what to go across with your x on your x-axis, and you need to find your range in your y-axis to find out what you should label your numbers on your y-axis. I hope now you understand scatter plots. Have a great day.